Hey everyone, and welcome. So, if you've been coding in Python for a little while, you're probably getting the hang of loops. But have you ever wondered what happens when you put a loop inside of another loop? Well, that's exactly what we're going to tackle today, this really powerful idea of nested loops. We'll see how you can use them to go from drawing a single line to creating these awesome, complex grids and patterns. All right, let's get into it.
So imagine this. You've totally mastered the for loop. You can whip up a line of circles, a row of squares, you name it. But then you kind of hit a wall. How do you take that one column you just made and repeat it side by side to build out a full grid? That's the puzzle we are going to solve right now.
Okay, let's start on familiar ground. Check out this code. It's just a simple for loop, nothing fancy. The I variable is just cycling through the numbers 100, 200, and 300. For each of those numbers, it draws a circle at a fixed x position of 50. The result? A single vertical column of 3 circles. Simple enough, right?
So the next logical question is, okay, cool, I've got one column. How do I get, say, 4 of them? We need to repeat the action of drawing a whole column over and over again. And what's our number one tool in programming for repeating pretty much any action? You guessed it, it's another loop. And that is the big idea right there. If one loop can repeat the action of drawing a single circle, then a second, bigger loop wrapped around it can repeat the action of drawing an entire column of circles. And that brings us to the main event. You see, making one column just needs that single for loop. But to get the whole grid, we need a loop that lives inside of another loop. This cool and powerful structure actually has a special name. We call it a nested loop. It's a simple name, but it's a really powerful concept. You've got your outer loop and your inner loop, and the way they work together, well, that's the most important piece of the puzzle to understand. And here is the golden rule, the one thing you really need to remember. For every single pass of the outer loop, the inner loop runs completely, start to finish. Think of it like this. The outer loop takes one big step, then it just pauses and waits for the inner loop to do its entire job before it even thinks about taking its next step. Let's trace that out. So here's how it flows. First, the outer loop kicks off and sets our x variable to 50. Then, the entire inner loop runs, drawing that first full column of 3 circles. Only when that inner loop is totally done does control go back to the outer loop. It runs again, this time setting x to 150. And then the whole process repeats. The inner loop runs completely again, drawing that second column.
This table shows you the same exact thing, just with the numbers. See how for the first 3 circles, the x value is totally locked in at 50, while the y value cycles all the way through. Only then does x finally get to change to 150, which lets the y value do its full cycle all over again for the next set of circles. Now look, this method of looping over the exact pixel numbers, it works. It works perfectly fine. But in programming, we always want to think a little more abstractly, a little bigger picture. And there is a much more common, a much more flexible way to build grids that separates the idea of the grid from the nitty-gritty pixel locations.
And that's by looping through row and column numbers. So instead of thinking about x and y coordinates, we're thinking about the grid structure. We'll have an outer loop for the number of rows, 3 in this case, and an inner loop for the number of columns, which is 4. So why even bother with this? Because it separates your logic. The loops are just in charge of what row and column am I on. And then some totally separate formulas handle, okay, where on the screen does that actually go? And that separation is so powerful. It means you can easily do things like say, hey, if the column number is 2, make all those circles blue, without having to mess with your main loop structure at all. So how do we translate our abstract call number, like 0, 1, 2, or 3, into a real x coordinate? We just use a simple formula. We can start at a base position, let's say 50, and then for each column, we just add 100 pixels. The exact same logic works for converting the row number into a y-coordinate. This gives us complete control. And this right here, this brings us to the single most common stumbling block when you're starting out. I mean, it is so easy to get this mixed up. Our brain just thinks, well, a column is vertical, right? It goes up and down. So shouldn't the call variable control the vertical y position? But here's the key. You have to remember what call is actually referring to. It's not talking about one little circle in the column, it's talking about the entire column as a group. And if you look at 2 different columns, say column 0 and column 1, what's different about them? It's their horizontal position, their x position that's different, not their vertical one. So let's lock this in with a super simple rule. Call is for columns, and columns arranged side by side, horizontally.
So you use call to find the X position. Row is for rows, and rows are stacked up vertically. So you use row to find the Y position. Just burn this into your brain. Call for X, row for Y.
Okay, let's wrap this up with the key takeaways. First, a nested loop is just a loop inside another loop. Second, and this is the big one, the inner loop runs to completion for every single iteration of the outer loop. And finally, when you're building grids like a pro, just remember, column for the X position and row for the Y position.
You now have one of the most fundamental, most powerful tools in programming at your fingertips. Seriously, grids are the foundation for everything, from checkerboards and spreadsheets, all the way to level designs in video games. So the only question left is, what are you going to build with it? What amazing patterns will you design? The canvas is all yours. Happy coding.